the MIG gun that we're holding in our hands is going to have a small roller in it that's going to help pull the wire from the machine, and at the same time we usually have one on the inside of the machine that is helping push so we don't create a tension to where we snap that aluminum really easy, okay? It feeds the wire through a cable assembly to the gun arc and the weld puddle. This cable assembly is usually referred to as our flexible liner. And what happens, the liner can get a lot of gunk in it. It can get dust, grinding dust, metal particles. It can also just get wore out. If a piece of metal eventually will wear a hole into it. And then you start having some wire issues as well. You'll notice real erratic arc. You're constantly fighting whether the wire speed is in good shape or the wire speed is welding good, and then the next second it's not feeding right, you're having some problems, it seems like there's some hesitation within the liner or within the wire feeding process, and those are usually symbols that are going to tell you maybe we should look at the liner and possibly replace it as well. Okay, they don't go out a lot, but if you're using it quite a bit, you might go through one liner a year, one liner every 2 or so, depending on the type of current and how much welding you're doing. Okay. Read through this. Most wire feeding units push wire through the cable to the gun. Here's the big portion right here that I think is just so important. So here's a good example of a welding machine that the spool of wire is going to be stuck right inside of the unit here. You'll lift this up, the wire will be in there. It doesn't have an external feeder. You can tell that because the gun's coming through here, wire is fed down through this. Okay? Sorry, wrong direction. So there's a few things that I want to point out. And I want to get a little bit closer here. So I'm going to walk up there now. Okay. So you have your inlet guide, so your wire is going to come through here, and usually at this point is where you want to put, I've used just plain earplugs to help keep some of the grinding dust out of it, but they do have some pieces that you can buy at the supply house that'll have some automatic lube on it to kind of help feed things through as well, okay? But there's some sort of restrictor here to keep the grinding dust out of your main chamber, or it should be. It's not 100% sealed. You're eventually going to have to blow these out and keep these cleaned out. Now, at some point, you're going to have to replace the wire on your machine. I'll walk you through this as well in the shop. But before, I don't think that they went through this enough. We need to describe a few things in here, break down the parts for you. So right here is your adjustment, your tensioner adjustment. So what it's going to do is it's simply just a spring. Normal bolt pattern, the clockwise position, righty-tighty, is going to put more tension on your rollers and smash this down. Lefty-loosey, counterclockwise position, you're going to put less tension on your rollers, okay? And also, so your wire's in there, so you're not going to be putting as much pressure on your wire as you loosen. More tension, more pressure on the wire as you come through. 90% of the time, these are over-tightened. They're over-tensioned. People will start having problems with it feeding, and the first thing they do is they reach down there and they just crank it down. And that's the wrong thing. We don't want to do that. Usually we can hold our wire up, and if we bring our wire out and it really curls back, we know we have way too much tension. We're kind of like, we're putting a kink into that material as well, okay? So at this point, we bring our wire through, we bring our wire into our main guide, and we have to watch these guides here. There's a wing nut here that locks this into place, okay? You don't want this inside of your rollers and catching because it'll drag material and it'll start rubbing the material off of it and get pulled into the drive roll eventually. You want to set it in your rollers, and then it comes out, and your wire, your MIG gun's going to slide into here, and at this point you lock this down. Now your gas line, Your gas line usually feeds in here on the top side. This one may be an internal piece within it. And it's going to come down, and there's two O-rings where your gun sits into here, okay? And I'll show you how to check those. Make sure they're not dried or cracked, especially in a dry climate like this. You constantly checking the O-rings. If you're getting a lot of porosity within your weld, this is one of the first things I'll check. I'll check to make sure my O-rings aren't cracked, allowing a lot of gas to escape before it has a chance to travel down my liner and my MIG gun to help protect the gaseous puddle within the weld. Okay? So now let's talk about the rollers. Next one. Okay. One of the most inconsistent things that I've seen is people putting the wrong rollers in for the wrong application. Okay. The V-groove, this is for a hard wire roller. So it's, if you notice, it's smooth. Okay. It does have somewhat of a U-groove to it, not just a straight V-groove. What we usually see is like this. This looks a little drastic for me. But it is more of a U to a V-groove for the solid wire pieces. So for our normal GMAW process, we want to make sure it's either a V-groove or a light U-groove, matching the 035, the correct wire diameter that we're using. Now the knurled one, this is where most people have the mistake. They think this knurled one's the one that's supposed to catch the solid wire, but the knurled one's actually for the flux core. So it's a tubular wire, and if you smash this down too tight, you really know what's going on is you're constricting that tubular wire, and you're really putting a kink into that material as you're going through. Part of the reason it has that is so you don't kink that wire, and it helps create traction as you're pushing that tubular wire along, because it's got a thin wall versus the big thick wall of the solid wire. Okay? So that's just something real simple. Flux core, solid wire. Flux cores have knurls. Solid wire does not have the knurled rollers. Okay? And of course, naturally over here you can get into some extreme rollers for like hard facing types with some major alloying and so forth. But majority of what we're dealing with, knurled for flux core, solid wires do not have knurled rollers. Okay? Going to, guess I should have backed out on that. I think we got the point though. All right. Welding guns. This is what the MIG or the welding gun from your power source, your machine. And this is what you are physically holding. So, sorry I jumped ahead there, but I'm going to take a second where I want to show you this picture as well. Okay? Almost dropped this thing. So what I want to show you is this right here. So these are two options of a suitcase welder, okay? So you have an engine-driven machine. You don't even have to have an engine-driven machine. You just have to have a power source, okay? On the left-hand side, it's a Miller welding machine. On the right-hand side is a Lincoln LN25. These are suitcase welding machines. So inside the side of them, over here, this piece, this section will come open, the wire roll fits in here, you've got a welding lead, you hook it, you hook your power source into it, your gun comes out, and then you can weld, okay? So this is a really good option for, say if you're in the middle of the air on a skyscraper, and you need to carry a suitcase up there, then you can hoist this up there without running 500 miles of wire, or 500 feet of wire, I'm sorry. Because that's unfeasible, okay? So we take the suitcase, we'll run a welding lead up there, we'll set it to a constant voltage, and then at that point we can control all of our wire speed and so forth right off of the machine here. either one of them. They're both good machines. I've ran both. They're an extremely valuable piece of equipment to be able to weld in the field. Okay? All right, so getting back to more. Let's talk about the push-pull wire feed system. We talked about it for aluminum. Here it says it was designed specifically for aluminum. Pull drive motor in the gooseneck, while the control on the wire spool housing has a push motor. You can read through these. Let me show you here. So a pull type gun. So let's see the roller. This doesn't have it. So here's your spool gun. So instead of having an aluminum wire that sits in the machine and it's pushing there and pulling at the top, you're going to buy these little spools of aluminum wire that fit right onto this. We have this exact same gun in the shop. Very handy gun. So the aluminum's fed from here, your gas ties into it, pull the trigger, your power comes through here. It's all self-contained within that unit. Okay? But they're small rolls of aluminum. They're kind of awkward and out of position. However, the main thing I wanted to show you is you see right here on this, we've got a set of rollers, and that's very similar. Even on the other MIG guns, you'll be able to see different types as well. So, again, in your book on page 696, there's a picture of a machine with a more in-stream, in-line pull type gun, welding gun there. Okay. Water cooled, you can get water cooled units for the most part. Again, I don't know of many places that do run them unless they're doing heavy industrial welding, so forth. As you can see, there's a lot of O-rings. Anytime there's an O-ring, there's a chance for a gas leak. Okay? Plain and simple. Liner, O-ring, O-rings, O-rings. So number 5 here, this is your lock nut coming in through here, down to the nozzle adapter and contact tip. Okay? Usually on the aluminum, you'll go through quite a bit of consumables, contact tips, and so forth. Water circulating units. The place you're going to see the majority of this is by far on your gas tungsten arc welding equipment. It helps keep the handle cool, and even with the water cooled torches, water cooling units, you'll notice that TIG torch will heat up very, very fast. Okay. So before we move on, I want you to go back to the book. And I just want you to kind of, on your own, browse through 696, 697. Any questions you have, come and ask me. So forth. Okay. Water circulating units. They're an internal part of the gun. One of the problems that can happen from time to time is you have to make sure that number one, you make sure you keep that the pump comes on when you turn the welding machine on. I've seen several times that you'll turn the welding machine on, and a lot of times the power sources are 2 individualized units. Okay, they're not plugged in together. Ours here in the shop are plugged in together. However, I want you to make a habit. When you turn the welding machine on, you make sure the water-cooled pump, you'll be able to see the veins inside of the pump signifying that it's running. I want you to make sure it's running, okay? But on several occasions, I've seen folks go in, they've turned the welding machine on, they forgot to turn the pump on, and they've started welding, and next thing you know, they've melted a hole inside of the TIG line, or the TIG torch. A lot of those TIG torches usually run minimum $100 to $200 at a time, and not a lot of places keep a lot of them on stock, especially depending on what model machine you have. Okay, so to start with, the most important thing: make sure it's running, make sure it's not leaking, and if so, then let's make sure we fix the leaks, and we try not to let anything drop off of the machine that would cut through and cause a leak within the machine as well. Our shielded metal arc welding cables are pretty heavy and industrial, but when we get into water-cooled units of TIG torches and MIG torches, it can be pretty delicate pieces of equipment, especially if we're running like bevel plate and we're grinding around, one of those pieces falls off, you know, it's 2 or 3 pounds, it can easily go and poke a hole right inside of the liner of the water-cooled TIG torch. Okay? So number 1, turn the machine on. Number 2, make sure that your water-cooled machine is running as well. Water circulating unit is running as well, sorry. Occasionally you're going to have to change things out within this water circulating unit. Read and refer to the owner's manual as far as how much antifreeze and how much water. Okay, sometimes for the most part, we've done a 50-50 mix. Hotter places, you may not get cold, but you refer to the machine manual and your current atmospheric and shop conditions, and mix your antifreeze and water according to that. Okay. I've known people that have run only water in them. There's not much lubrication value in water. I believe you need to have some in there to help kind of keep everything moving along nice. It helps with the longevity of the pump as well. Okay. Again, refer to the manufacturer's manual as to percentages.